Alright, so we're going to start with section 7, topic 5, growth and decay rates of exponential functions. This is a very easy lesson. All it is we're learning about, is my graph going to grow or is it going to decay, which means drop. Okay, so consider an exponential function in the form of f of x equals a times b to the power of x. Remember, this is the formula for an exponential function. Okay, every single formula would look like that. Assume that a, so a is the, what do we call the a? Well, we've talked about it before. It's the y-intercept. Okay, if we didn't know that, you should know that now, that the a is always the y-intercept. And it's saying that assume that a is positive. Okay, so in this theory, we're going to assume that a is a positive number. Okay. Then it says if b, and b represents what? What does b represent? We've talked about it before, and b represents what we call the common ratio. Okay, so a is always the y-intercept, b is always the common ratio. Okay, and it says if b is greater than 1, we say the function is, so if my number is greater than 1, then we call that a growth, and it's growing. Okay, so that is a growing decay. Okay, I'm sorry, it's a growing rate. A decay would be decreasing. Okay, if b is 0 and 1, the function is therefore decaying, so it's dropping. So any numbers between 0 and 1, that means my graph is going to decay. And we've talked about this and how they look if my graph is a 1/2 versus my graph being a 2. Okay, so what are some examples of exponential growth? So some examples you could think of is, for instance, a virus. So the number of people with a virus. So if you think about it, any type of virus, even a cold or a flu, when one person gets it, a whole bunch of people start to get it, and then we have what we call an epidemic. Okay, that means that it just starts growing and growing and growing, and it grows in big numbers. Okay, another thing is what we would call interest. So interest, and we'll say it in a positive way, interest for a savings account. So if you ever have a savings account, which I highly suggest you start to invest in, start putting money in there, and then what will happen over time is that interest will start to accumulate and it'll start getting you more money. Okay, so that's a part of a growth, exponential growth. Now, what are some examples of exponential decay? So one that comes to mind is a car. So a car price over time. If you ever buy a new car, the minute that car leaves the dealership, that car decreases in value. And then every year, that car will decrease in value each year. So that's why if somebody asks you for a brand new car, you're paying a very high price. But if you're asking for a car that's about 2 or 3 years old, you're asking for a lower price because, well, it's dropping down each year. Okay, just makes sense. Exponential decay. Another thing you can think of, and this is really word to word, is the size of a dying tree. So trees will actually start to decay themselves and start to lose their length of the tree, and then over time it'll eventually either fall or it will shrink itself to non-existence. But we don't really see that a lot because it takes a lot of time for that to happen. But that is an exponential decay. Okay, so exponential growth is when it's happening really fast in a positive atmosphere. Exponential decay is when it's happening very fast in a bad and a negative atmosphere. Okay, let's move on. Let's practice. So problem 1 says consider the exponential function f of x equals 500 times 1.05 to the power of x which models the amount of money in Tyler's savings account, where X represents the number of years since Tyler invested the money. So, is the money in the account growing or decaying? So first of all, if we look back to the first part, if B, the common ratio, is greater than 1, the function is growing. So let's look back at my problem. The problem says f of x equals 500 times 1.05. So my A in this problem is 500. My B in this problem is 1.05. And what we just read was that if my B is greater than 1.05, it would be considered a growth. So this right here is growing because B is greater than 1. All right. So what is the rate of growth or decay? So how this works is you're going to take your B, which is 1.05, and you're going to subtract it to 1. The reason I'm subtracting it to 1 is because in the statement that we just read, it has to be greater than 1. So that's where the 1 comes from. So you're always going to take that B and subtract it to 1. Now, whatever your answer is how much you are growing. So 1.05 minus 1, that answer is 0.05, which means that my growth is 5%. Okay? And when we're talking about interest, 5% is about normal. Okay? All right. Let's move on to what does 500 represent. So we talked about what A is, and A is the 500. But what does it actually represent? And if we look back at the top, it said A represents the y-intercept. Okay? So if A equals the y-intercept, in this problem, that would mean what? Well, consider the exponential function, f of x equals 500 times 1.05, which models the amount of money in Tyler's savings account, where x represents the number of years since Tyler invested the money. So $500 would represent how much money he had at the beginning. So 500 represents the initial amount. Okay, so he started off with $500, and each year it's going to increase by 5%. Okay, now consider f of 8 equals 738.72 77.21.89.5. While this is correct, what is an appropriate answer in this context? So is this an appropriate answer in the context? So what does this number represent? What does the answer represent? So if we're talking about this problem, and we'll look back right here, consider the exponential function f of x equals 500 times 1.05x, which models the amount of money in Tyler's savings account, where x represents the number of years invested since Tyler invested the money. So the number right here would represent the total amount after what? This represents the total amount after 8 years. So how much money I have after 8 years. But can I write 738.72 blah blah blah, all that? Do I write it like that? No, because we're talking about money. So I would say no. The answer is 738.73. Okay? Because when we're talking about money, and because we are talking about money, and because we're talking about money, I can only take the first two numbers after the decimal. Okay? It just That's the only way I write my answers. So, although that whole yellow highlighted area is correct, I can only take the first two decimals. Okay? So, you will see the rate of growth expressed as a decimal or a percent. So, we always have to have the growth as a decimal or a percent. And remember, how you find the growth or decay is you take your b minus 1, and whatever the answer is the growth or decay. Okay? That's it for this video.